In MJM palm oil mill, the final products that we produce are crude palm oil, also known as CPO, and palm kernels, known as PK. Some byproducts will be obtained throughout the process, such as palm kernel shells called PKS and bunch ash. Fresh fruit bunches, also known as FFB, are processed in the palm oil mill to obtain the aforementioned products. Firstly, the FFB are transported to the mill from various FFB suppliers. The FFB are weighted by using automatic weighing system, which is fast and convenient. FFB are first graded to determine the FFB quality before unloading at the loading ramp, which in turn are then stored in the hopper. During operation, the operator loads the FFB from the hopper into the conveyor. The conveyor then transfers the FFB to the feeding area where 4 empty cages are ready to be loaded. One cage carries approximately 15 metric tons of FFB. The filled cages will be transferred from the feeding area to line up in front of the sterilizer using transfer carriages. 4 cages are lined up waiting to be pulled into the sterilizer using a winch system. The function of a sterilizer is similar to the function of a pressure cooker. Lipase enzyme deactivation to prevent deterioration of CPO quality occurs throughout sterilization process, making fruitlets easily detached from bunches and softer, while making nut separation easier and allowing for the coagulation of proteins. The front door of the sterilizer will be opened and the drawbridge will be lowered in order to transfer the cages into the sterilizer. The doors and drawbridge are fully hydraulic operated, and each cycle of sterilization can hold a maximum of 4 cages, and the FFBs are sterilized at pressure around 40 psi and takes 90 minutes. After the sterilization process, the cages will be transferred to the tippler using hydraulic indexer. The tippler will turn the cages and unload the sterilized FFB into a hopper. The tippler and hopper door are also hydraulic operated, and feeding sequence is set in such a way to achieve meal throughput. The empty cages will then be pulled out from the tippler and transferred to FFB feeding area again by using a series of hydraulic indexers. At the hopper, the sterilized FFB are fed into the thresher drum using conveyor, where the fruitlets will be stripped off from the bunches. The fruitlets, after stripped off, will be fed into the digester, and the bunches will be transferred to the EFB pressing station. The digester will mash up the fruitlets so that when the mash is pressed in the screw press, the oil will be extracted efficiently. The output of the screw press is crude palm oil and press cake. The oil that is extracted from the press contains high level of moisture and impurities, which is further processed in the clarification station to reduce moisture and impurities to an acceptable level, while the press cake is fed into the cake breaking conveyor, also called the CBC, to loosen the cake for easier separation of fibers, nuts, and kernels at the deep pericarping and kernel recovery station. The crude oil from press flows to the sand trap tank to remove bigger impurities such as sand. Finer impurities are further removed using 4 vibrating screens. The oil will then flow to the crude oil tank where steam is introduced for oil and sludge separation. This is because crude oil is highly viscous and high temperature is needed to carry out the separation of oil and sludge more effectively. The crude oil obtained from crude oil tank is pumped into the pure oil tank, where the sludge is pumped into the clarifier tank to further separate sludge and oil. The oil is skimmed from the top of the clarifier tank and flows into the pure oil tank, while the underflow sludge is fed into a sludge tank. The oil in the pure oil tank is pumped into a purifier to remove finer impurities and then pumped to a vacuum dryer to remove excess moisture in the oil. The acceptable level of moisture and impurities should be controlled below 0.25%. The final purified crude palm oil is now ready to be pumped to the storage tank to be sold to the refinery. Sludge from the sludge tank will be further processed at desander, followed by a decanter to further recover oil from the sludge to minimize the oil losses. On the other hand, loosened press cakes undergo separation at winnowing system, where the fiber, which is lighter, is separated from nuts and kernels using pneumatic separation. The lifting velocity difference in fiber, nuts, and kernels will cause fibers to lift while nuts and kernels to drop. The fiber will then be transferred to the boiler house as biomass fuel for the boiler. Nuts and kernels will drop into the nut polishing drum. The nut polishing drum is designed in such a way that the size of the nuts and kernels will pass through the holes at the drum, while bigger particles will fall off at the end of the drum. Beneath the holes of the nut polishing drum is a conveyor transferring the polished nuts and kernels to destoner system to remove stones among the nuts and kernels. The nuts and kernels will then be transferred to the ripple mill where nut cracking occurs. The cracked mixture will then be transferred to a two-stage winnowing system where lighter shells, also known as dry shell, are separated out from the mixture also by using pneumatic separation. The dry shells are stored and ready to be sold or used as biomass fuel at the boiler. The cracked mixture, after going through two stages of winnowing system, will then be transferred to the three-stage hydrocyclone. In this stage, heavier shells are separated out from the mixture using wet separation. Kernels are separated at the first and second stage of the hydrocyclone, while wet shells are separated at the third stage of the hydrocyclone. After that, the wet kernels will then be processed to a kernel drying silo to undergo drying process before stored in the palm kernel bunker and ready to be sold. On the other hand, wet shells are directly stored into the palm kernel shell bunker and ready to be sold or used as biomass fuel for the boiler. At the EFB press station, the empty bunches are further pressed to recover the oil absorbed in empty bunches. After pressing, the empty bunches will be transferred to the incinerator for burning. The ash obtained from the burning of empty bunches is known as bunch ash, where the ash will be packed and sold as organic fertilizer. Bunch ash is widely used for peat soil oil palm plantation due to high alkalinity, which is able to neutralize the acidity of peat soil. MJM palm oil mill generates its own electricity by using steam turbine and diesel generators to supply electricity to the whole mill and even the workers and staff quarters. Besides that, MJM palm oil mill also has its own water treatment station to supply clean water within the mill compound. Therefore, MJM palm oil mill does not require any power or water supply from external sources. In addition, to be a more environmentally responsible organization, MJM palm oil mill even has its own decanter cake dryer plant, wastewater and dewatering plant. This is to minimize the pollution load to the environment to conserve best living environment for our next generations.